Buenos dias, fuckers. Buenos dias. Can I use the other term? No. Once? The fucking globers. No. Fuck as it is. Now, I had a day off yesterday. It was a well-deserved day off. I was going through the comments. Not on my posts, just flat earthers, globers, flat earthers, globers. The globers. Can I once? No. Globers, right? They've got this thing. They say things like, well, how does a solar eclipse work with the flat earth system? And I hear it and I go, how does a solar eclipse work with a round system? Why is it that the sun is directly behind the moon? Where is the explanation for that, globers? You're asking how the flat earth, you're asking questions that no flat earther would know. But you don't know how your own solar eclipse works. The moon comes out of nowhere during the solar eclipse. Boom, stops, parks up, 8 minutes, doesn't move. Explain. Explain. What is that? No explanation, yet you've got the front to ask us. Yes, I am a flat earther now. You want an explanation. You don't know how your own freaking solar eclipse works, but you want us to tell you how ours works. We don't know. Nobody knows. This is the thing. It reminds me of those people that used to say, with the speed of light. Well, how does GPS work then? It's what the sun and the light it radiates is like water coming out of a hose. That's something Newton would say. You need to stop everybody going, well, how does this work? How would that work then? Don't we understand that we don't know? We don't know how things work. We don't even know how our things work here. Gravity's another one. Well, if it's not spinning, how is gravity cranked up? Are you kidding me? There is no gravity. We know for a fact that the moon does not affect the water on Earth. We've worked that out. It's easy. Firstly, the 4 highest tides are all up north. Bay of Fundy, Ungava Bay, Bristol Channel, and the Cook Inlet in Alaska. That's a massive one. They're nowhere near the equator, where the moon is orbiting. Nowhere near. Then we have, why is there no action at the equator? Where is the bulge? Where is the bulge? Where is the bulge? What else is there? Tide comes in, stops for up to an hour, and then drops back the same way it came. Could you please explain that one? No, you can't. Nor can anybody else. So stop asking for how a solar eclipse, can I use that term once? The fucking globers one. No, you need to stop asking stupid questions. Do you get it? We don't know. The thing is, you've just been brainwashed. Everything has an answer. You think you have answers to everything. You don't have answers for anything. You don't even have an answer for gravity. You just don't. It hasn't been proven. You've just been lied to, and you think you have all of the answers, but you don't. Now, that's out of the way. This all started because I drew this. On the 12th of August, just under a month from now, there's a solar eclipse happening in the Mediterranean where I grew up. So I thought I'd get cranked up with the absolute light, no light delay. Why is the sun directly behind the moon? I drew that. I was just going to start doing the little details and thought, it's so wrong when you see these explanations. The bulge. and they draw solar eclipse paraphernalia and this and that and the axis spin. It's the scale. It's when it's all on a blackboard, it looks so easy peasy, Japanesey, doesn't it? But it's not like that in real life. So what we have here, I decided, instead of doing the sun, you know, I usually say, right, if the sun had a diameter of 3 millimeters, then X would be so far away and that would be so far away. Today, we have Earth. It has a diameter of 1 centimeter. What's that down there? What is that? That is the moon at the top. Right? That's the moon. And they are on a ruler 30 centimeters apart. This, folks, today I said, right, planet Earth, 1 centimeter. How far away are we from the moon? 30 Earth diameters. 384,000 average distance divided by 12,742. There are 30 Earth diameters in between Earth and the moon. If Earth has a diameter of 1 centimeter, what diameter is the moon? Well, if we divide 12,742, Earth's diameter, by 3,476, the moon's diameter, we get the number 3.66. We call it 3.6. If we divide 1 centimeter by 3.6, we get 2.7. The moon has a diameter of 2.7 millimeters. It is just about perfectly to scale with a 1 centimeter diameter Earth and a distance of 30 centimeters between them. So there you are. But there's something missing, isn't there? El Sol. The sun. How big is the sun in this situation? Anybody? Bueller? 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 Exactly. 1 meter and 9 centimeters. How do you know? Because there are 109 Earth diameters in the sun's diameter. And how do we know that? Because we divide the sun's diameter by Earth's diameter. 1,390,000 divided by 12,742. 109. 1 centimeter diameter. This post, this stick, 1 meter and 9 centimeters. The sun's diameter, but of course I'm not going to just do this stick. I've got one that I prepared earlier. So I'm going to pause your asses and be right back. And here we are. So this has a diameter of 1 meter and 9 centimeters. To scale with the numbers that we're given, 1,390,000 kilometers in diameter. 1,390,000 kilometers in diameter. Earth, 12,742 kilometers in diameter. The moon, 3,476 kilometers in diameter. These are to scale. How far away would this sun be? We know there are 108 suns in between the sun and Earth. 108. If it has a diameter of 109 centimeters, we multiply that by 108 suns, because 150 million kilometers divided by 1,390,000 kilometers is 108, or 107.9. We round it up to 108. 108 times 109 is 117. to scale this planet Earth with that moon, that distance apart, and this 1 meter and 9 centimeter diameter sun at a distance of 117 kilometers. That's how far. So when you see these Mickey Mouse things on educational stuff, it kind of misleading, isn't it? So what we're going to do, I'm now going to walk this down to about the 33, 34, 35 meter mark. I'm going to go a third of the distance that the sun would actually be. Now, there is a thing here, because what I've done, there is a line attached to this, and that line is going to go into this board. It doesn't matter how far away I move with this sun, right? Its diameter is always going to be 109 times bigger than Earth's. It doesn't matter how far away it goes. If I tie a line to the top and to the bottom, as I move it away, the lines stay. They don't do the whole, like the parallel train tracks that get closer and closer. They won't. The sun may get smaller and smaller and vanish because of distance, but the diameter size, the 109 times, that stays the same, right? Now, it's important because Earth, look at the size of it, look. You know those sun rays that come out of clouds and go left and right, and how does that happen with this diameter sun? Doesn't matter how far away it gets, does it? A solar eclipse. It's a big sun, isn't it? But it's 117 kilometers away, meters away. So, what I'm going to do now, I'm going to walk, settle Earth, I'm going to walk down to there, right? And I'm going to take this sun, diameter sun, with me. And when I come back, we'll talk some more. Oh, stop it, Earth. Now, there is your Earth. I think you'll probably be able to see that. Stop it. Right, here we go. Remember, the diameter, ground, and here, a line. It's never going to get smaller, is it? Right, so here's the line coming back. So it's about a third of the distance, 30 something meters, right? You see this line? So I'm going to put this line on this board. It's about 110 centimeters up instead of 109, but because we're among friends, I don't think that's going to matter. So I now stick this into this hole, and 9 months later it will have a baby. See this? That string, got a fishing line all the way down there to where that sun is, by that mirror. Oh no, 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 no. So there we can see the hula hoop and the line tied to it, right? And that line comes all the way back to here. And Earth and the moon, it doesn't matter how far away that sun gets from here. The line that its Earth is always going to be 109th of the sun's diameter. There's not going to come a time where for some reason the line in between gets narrower and narrower because the sun's moving away. It doesn't work like that. It has a diameter of 109 times Earth. Could take it 20 trillion quadrillion kilometers away. It's still going to be the same line, the same size, the same 109 times Earth's diameter. Knowing this, Saturn, Earth, knowing this, the first question that arises is, this, when there are clouds, and we see these rays of, so here's Earth, well, I have to do it white, you see, have clouds, and we see these like this. What's that? What's that? We just see the sun's diameter is 109 times. Earth fits in that 109 times. The sun's way behind. Why do we get those, was it crepuscular? How does that happen again? Knowing the diameter of the sun and the distance that it is, what is the explanation again for this? Could be a local sun, couldn't it? But that's a cheap way out. Knowing that the diameter is so big of the sun, it's logical to think that the rays do come parallel. If it were round, this is about the Eratosthenes ridiculousness. It didn't happen. He didn't measure. 200 BC. He's in one place. That's not the name. It's in Egypt and Alexandria or something. The point is, it's 900 and something kilometers away, these places. 200 BC. So, he's in one place and he says, a well. There's no shadow. The sun is directly above me. I know a place in Alexandria where there are shadows right now. Huh. Listen. No cars, no mobile phones, no nothing. Just donkeys and horses. 925 kilometers between the two places? How long would it take somebody to travel 900 plus kilometers in the year 200 BC? Just 900 and something kilometers. How long? A few weeks, right? Now, by the time he got to this other place, the sun has already shifted in the sky. That's first. Secondly, there's no mobile phones. Hey, are you there? Yes, I am. I'm looking down the well right now and the sun is directly above me. There's no shadows. What's happening down there in Alexandria? Do you see shadows? Yes, I do, Ratos. That didn't happen either, did it? So how did they compare from one place the shadows of the other place? I can hear the can I use that term? Yeah, the fucking glow. No. I can hear them coming up with all this Mickey Mouseness, all these excuses, reasons for why it was possible. You, with a friend, find a time when the sun is directly above you, right? Dig a hole and wait for the sun to be directly above you. And then 915 or 925 kilometers away, there should be shadows. So the sun won't be directly above, right? Because it's that far away, or is it because it's round? Here's the thing. Now, if it was round, you would get a shadow, wouldn't you? You would get a shadow. So, is this an advantage for the globers? Even though that sun is, and its diameter is massive, 109 times the size of this, shining on it, Egypt, right? So let's just say, it's like that, right? And the sun is directly above and there's no shadow in the well, it's right in the middle. And then here, at 900 kilometers away, whatever it is, there would be a slight shadow, wouldn't there? Because round. So, but, is it round? What do we have? What do we have? I tell you what we have. Yesterday or the day before, on TikTok, somebody said, you just debunked yourself. Those pencils, Norway and me, he reckoned that I somehow had them both parallel. I'm saying that Norway cannot be seeing the sun so low over its horizon at the same time as me in northeast Queensland, southeast Queensland, is seeing the sun where it was in my morning horizon. And people are going, no, of course they can see it at the same time. No. It's the angle. So I had pencils, didn't I? So we've stepped up. You can go line. We're coming to the end now. Coming to near the end. Once again, here we are. Now, I went and got some 1 meter rulers. You can't have enough 1 meter rulers. Now, what we have, Norway. This, oh, stop it, will you? God. Norway. If I turn this phone off now, I am going to get the cacas. Right, stay like that, we're nearly done. After 24 minutes, you do as you're told. Norway. Right? I'm not going to lie to you, that stick is, give or take, an arc minute or an arc second or an arc minute second. That is the direction that Norway is looking. Northeasterly, it changes as the days plod on, but they were looking northeasterly and I was looking northeasterly. We were both close to north. That is the angle, folks, across over the horizon. Queensland, me. Again, this is the angle that I would be looking up at. Right? I didn't make this up. You can see it on the globe. Now, this is where they are going. You could argue and say, well, maybe this one was here, or it's the angle. Don't forget, the sun, yes, it's 109 times the diameter of this, but we are 2 Earth diameters away from Earth, and we're already, look, there are 11,772 Earth diameters between Earth and the sun, 108 sun diameters. Where do you think these lines of sight? This is why I'm saying that Norway cannot be seeing the sun where it is in their northeasterly sky, so low, at the same time as I am here in southeast Queensland. At the same time on a globe. It doesn't work, because if the sun is 150 million kilometers away, how can we both be looking at the same sun 150 million kilometers away? Can you not see? It's not trickery, it's not witchcraft, it's not sorcery. It's the facts. Look, in fact, this one has come down, so it would be up there a bit more. There is a sun 150 million kilometers away. For 2 places on the same planet to be looking at that sun at the same time, they have to be parallel, because these lines of sight have got to travel 150 million kilometers and stay within 109 Earth diameters to both see that sun at the same time. It is impossible for that sun to be that distance. Therefore, it's a lot closer. Therefore, the shadows that Ratos reckons that he saw wouldn't have been because of the round thing. It would have been because of a local sun. These are facts. Line of sight. It cannot be. Now, can I use it once? That term. That. Globers. No? Alright. Fockers. The hand is faster than the eye when it comes to your science. Earth, I think you'll find it's flat. Alright, I will be back, folks. Laters.